Focusing on space. Welcome to Nugget 384. It wasn't but a few days ago that we were in Goldendale, Washington, at a state observatory. It was so cold that night.
It was definitely cool, but it was nice because it was clear.
It was amazing.
We're going to talk today about an article in Science News, March 23rd, 2024. We're going to title this James Webb Telescope. We have a few shots of the James Webb Space Telescope because a lot of times people don't know really what it looks like. But here it is. In this article, in an article from Inverse, how the Webb Telescope team built those startling images. First thing I want to do is discuss how they make these images, because a lot of people are left with the impression that the pictures that we see happens to be what the James Webb Space Telescope sends back.
So it's not as simple as us whipping out our P900, taking a picture, and then pulling out the SD card, putting it in the computer, and voila, there's our photograph? It's not that simple, is it?
No, it's not quite like that. Like this article says, the process of taking data off Webb's 4 imaging instruments and adapting it into a color image is part science, part art form. And that's true. Off of NASA's website, there is a page that shows the 4 instruments that they're talking about in this article. They go on to say the 4 images released this week were processed by just 2 people of the Space Telescope Science Institute and told Inverse how they did it. Now, something to keep in mind, I know we've done nuggets on this. They did the same thing with the Earth that we all happen to see. At NASA, Robert Simon is the guy that made the Earth image that everybody is used to seeing. He's called Mr. Blue Marvel because of it. He says, even in an interview, that he built up the image based on how people's expectations of how Earth looks from space. That's amazing. So anyway, just kind of keep that in mind. Not saying they're doing that here, but
the data that comes from the telescope's instruments is downloaded to Earth and sent to instrument specialists who refine the data and pre-process it into a usable form before passing it on to the image processors. And that's what Robert Simon does.
Exactly. For typical images, the processors might take up to 2 weeks to work on an image such as a Hubble release. But for James Webb Space Telescope, the early release images, they had to work swiftly to get the images ready to show the public. The pre-processing was done in just 3 days and the processing in another 3 days. They talk about the new data that they got.
When the processors first receive an image to work on, it comes as a binary file with metadata and an image in black and white. It's usually very dark. It shows up as black on our screen before we've done anything to it. And that's because it has an extremely high dynamic range. De Pasquale tells Inverse. Most of the information is contained in the darkest region of the image, and we have to get that before we can see anything. This is done in a process called stretching, which brightens the darkest part of the image without blowing out the brighter areas.
It goes on and on and on, just talking about how they do it. They did mention the Hubble Space Telescope.
Well, I know that we have been to Marshfield, Missouri a couple of times, the hometown of Hubble, and they have this model of his telescope out. I think it might be on the courthouse lawn.
Again, on NASA's website, they say Hubble is in low Earth orbit. You know, a lot of people, I don't think they know that. I think they think it's out there somewhere flying around.
I don't know where it is, but I know that what they say isn't true. Low Earth orbit would not be what people would pick even if it was C on a multiple choice.
No, not at all. Not at all. But also, we've been to a number of observatories. We love doing this stuff. We've been to Lowell Observatory in Flagstaff. We've been to Kitt Peak National Observatory south of Tucson. But let's get back to this article a minute. Early galaxies may be deceptively light. Conventional physics can explain odd observations, scientists say.
Reports that the James Webb Space Telescope broke the universe may have been exaggerated. Oh boy, here they go. They're retracting things again? Imagine that.
We've also been to Palomar Observatory. Of course, Palomar is famous for its 200-inch Hale telescope.
Well, I see you have this eyepiece circled, and that's very interesting because you have these ginormous telescopes and a small eyepiece. That just seems kind of weird. When we went to Goldendale the other day, I was shocked at the telescopes that we were looking through, that they were so small. I guess the quality of the light gathering has increased over the decades.
Well, it has, and they use larger mirrors now. And the larger the telescope, the more light gathering it can produce. And of course, we went up to Mount Graham in southeastern Arizona to see the largest binocular telescope on Earth.
That largest binocular telescope is owned by the Vatican, and it's quite interesting what they've named this telescope.
But I want to point your attention to an article we've done a nugget on before, but in April 30th, 2019, Scientific American did this article that says cosmology has some big problems, and they say an enormous amount. It's worth looking up the whole article. But it says today's space telescopes provide no direct view of anything. They produce measurements through an interplay of theoretical predictions and pliable parameters, in which the model is involved every step of the way. Well, that's pretty much a gobbledygook statement, but just keep that in mind also. And then, of course, Michio Kaku, which is he's the co-founder of string field theory. He's one of the premier theoretical physicists in cosmology today. And he says, in cosmology, we are off by a factor of 1 to the 120th. He says, in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. But in cosmology, we're off by a factor of 10 to the 120th. He says it is the largest mismatch between theory and experiment in the history of science.
And there's always Neil deGrasse Tyson, who says that 74% of what they know about the universe is dark energy, 22% is dark matter. He admits that they don't know what dark matter or dark energy is, and he resorts to saying that what they say they know, or what we would say they think they know about the universe, boils down...
And including about us, because he even says in us,
everything. Well, according to them, we're in the universe.
Right.
Everything, which boils down to only 4% of what they know, and we know that many of the things that they think they know, they don't really know.
Right.
In scanning through the article, it looks like it boils down to that when they popped James Webb up there, it started causing a lot of trouble for them, because what it was demonstrating, showing, providing information on was contrary to what they thought. You know, you have a great way of explaining why these telescopes are seeing more. It doesn't necessarily mean that they're seeing farther. They're just seeing better.
They have better light gathering capabilities is the main reason. They can gather more light. What I want to stress again, and I know we've done a nugget on it before also, mentioned it, the thing we need to keep in mind is what was taught 5 years ago was taught factual. But now, for instance, with this, they're saying, well, what we thought we knew is not necessarily right. People will argue that what they know today is absolute truth, but it's going to change tomorrow. And that's scary.
James Webb is giving us a new dictionary to translate the language of the early universe. But before we say, hey, we need to throw away everything we knew in cosmology, we should understand this language. Another section, these galaxies were dubbed universe breakers because they flew in the face of scientists' assumptions about cosmic evolution. There's the problem, is they're basing all of their scenarios on cosmic evolution. We know that evolution didn't happen, so when you start with a wrong premise, basically everything that you put forth based on that is going to be wrong.
It kind of goes back to that 2019 article I just read in Scientific American. The model is involved every step of the way. It has to be that way for them, but it wasn't. The Bible says that God made everything, and therefore all this stuff is not necessarily true. It's like going to museums. We love to look at the fossils and enjoy what they have and marvel at the beauty of some of the stuff. But it is not true what the signs say about the timing.
It's the lens that the people are looking through that print the information that goes on the label, on a fossil, an astronomy display, or whatever. As we said, we like going to these observatories. We enjoyed that night, even though we were freezing.
Yes.
It was very awesome. The gentleman who spoke was very well informed, but totally steeped in evolution. It's just really sad that there are not creationists in positions that can capture people with the truth of God's creation and what we're looking at when we look at the night sky.
Well, like this article ends also, it's talking about supermassive black holes. James Webb is observing the universe breakers to confirm their early ages. Quote, if even one, especially one of the really massive ones, is there, it's a problem. Well, that's an interesting statement. Another quote, we're doing this translation in a land where we don't speak the language, but you never know if your language skills are good enough. The point is, the information that they think they're getting or that they are getting is totally throwing chaos into what they've always taught as a fact.
As you're talking, I'm thinking about these photographs, these images, I should say, that they put forth. And the old saying, a picture is worth 1,000 words. They may have 1,000 words in this article, and most of it is saying that they don't know, or we're changing our mind, or this is making us rethink what we once thought, the typical scenario. But it's the images that are embedded in people's minds. Their imaginations run wild with them, and they think that this is Loctite science, when it's not. It's images created, like in this case, by these two individuals.
And remember, the 4 instruments that they are using to interpolate and extrapolate and make these images from, these instruments can pick up things that we can't see. And I use an analogy sometimes about even in any given room, there is a good chance that many people have a key fob to their car in their pocket. There's a good chance that we could turn an AM radio on and pick up a talk radio. We could pick up an FM radio and we could pick up stereo music. We could put a TV in there. We could pick up moving pictures. We could put all kinds of police scanners, fire department, all kinds of ham radio, all this stuff. These signals, these frequencies are in the room with us, but we can't see them. We could assign different filters and different colors to various ones of these instruments and cameras, and we could make our own nebula out of whatever's in the room, but that's not representative of what is actually in there with us.
Well, this may have been a little technical, but not really. But the bottom line is, when you see these pictures, be careful not to be mesmerized. Figure out who created them and what you're truly looking at. And remember, Hubble is just in low Earth orbit. I bet you didn't realize that. Don't forget to subscribe and share our videos with your friends. Thank you.